What is thermodynamics? Write this question in your composition book and answer it. Pause the video while you do. Thermodynamics is the study of heat and its relation to other types of energy. So let's break it down. Thermo means heat, dynamics means movement, so thermodynamics means heat movement or transfer. Let's review what we know about thermal energy so far. We know that temperature is a measure of the average kinetic energy of the molecules in a substance. We know that kinetic energy is energy of motion. And we know that the kinetic molecular theory states that all particles and all forms of matter are in motion. Therefore, the faster the particles are moving, the higher the kinetic energy, which means the higher the temperature. We are going to examine thermodynamics by looking at the lab that we just did. In the lab, we learned that specific heat is the amount of heat required to raise the temperature of a substance by 1 degree. The symbol for specific heat is a capital C, or sometimes a capital C with a little p. The units are joules per kilogram Kelvin, sometimes written kilojoules per kilogram Kelvin. The specific heat is a property of the material. This means the specific heat of water is the same no matter how much water you have. And specific heat is used to calculate heat transfer in the equation Q equals mc delta T. Let's examine this equation more closely. Glue the table of specific heats in your notes at this point. Q is the variable for heat, which is measured in joules or kilojoules. M is for mass, measured in kilograms. C is for specific heat, measured in joules per kilogram Kelvin. And delta T stands for change in temperature. This is always in Kelvin. You were asked to calculate the heat gained by the water on analysis question 1. Use the heat equation to do this. Make sure your mass is in kilograms and your delta T is in Kelvin. You will use the specific heat of liquid water. Make sure you include the correct unit with your answer. According to the law of conservation of energy, the heat gained must be equal and opposite to the heat lost in a closed system. That seems pretty important. I think I'd write that in my notes and maybe highlight it or box it or something. Let's translate this to the lab. Question 2 on the analysis asked, what is the heat lost by the washers? Well, the law of conservation of energy would tell me that the heat lost by the washers must be equal and opposite to the heat gained by the water. Now that you know the heat lost by the washers, you can answer question 3 on the analysis to find the specific heat of the washers. Use the heat equation, and the specific heat should be the only thing you don't know.